Hello friends, welcome back to the tetrahedron chemistry classes. So guys, this is my second lecture on Iupac nomenclature. In my first lecture, I have compiled all the basic concepts which are necessary to give the name to the particular compound, right? And I have also discussed the Iupac nomenclature of the alkanes there. And today I am going to discuss the Iupac nomenclature of unsaturated hydrocarbons. As you know, unsaturated hydrocarbons are those hydrocarbons which have either double bond or triple bond between the carbon atoms, excluding benzene. Benzene cannot be included in the unsaturated molecule, right? So if you have followed my earlier lecture, then what you can do, you can straightforward skip 34 minutes of this particular video, because in the first 34 minutes I have again explained or compiled all the basic things which are necessary to understand the Iupac nomenclature. Hello friends, welcome back to the tetrahedron chemistry classes. So guys, in today onwards I am going to discuss a lecture series on the Iupac nomenclature, and the full form of the Iupac is the International Union of Pure and Applied Chemistry. There are various roles actually which this Iupac actually fulfills. And you know, this Iupac, basically it is registered in Switzerland, and its administrative office, which is also known as the Iupac Secretariat, is actually in the Carolina, United States. And there are various functions of this Iupac. See, in simple words, what we can say, this Iupac is the world authority, and this authority generally do the chemical nomenclature, and which includes the terminology used in the periodic table and the various standardized methods for the measurements of the atomic weights and many other things. That means the large number of things actually has been done by this Iupac, and in the near future, whatever the new things will come, first of all it will go to the Iupac, especially when it comes to the nomenclature, right? So without wasting too much of time in this theoretical part of what actually is the Iupac and where is its office, I am quickly going to explain the today's topic, which is very much important for the beginners, especially if you are in class 11 and you have recently cleared your 10th result, and you are going to learn the chemistry in the class 11. So this lecture is very, very important for the 11th students, right? So first of all, you can see here what I have done. I have given you this particular example, and please note that if you find little difficulty or any kind of the difficulty in understanding the things, then don't worry, and believe me, after the completion of this lecture series, you will be able to solve any kind of the question based on the your Iupac nomenclature. You will not have any problem in giving the name to the structures or converting the structures to the name. You will learn all these things. But if you find little difficult, it's perfectly all right, perfectly normal, because there are various rules, and when you do the practice, only then you will be able to solve the problems based on this. So here I have given you the examples, and why I have given you this particular example, because it involves the various terms, right? First of all, you can see here I have numbered the carbon atoms present in the molecules, and the number of the carbons are 5. So please remember, whatever the number of the carbon atoms are present in the main or the principal chain of the organic compound, it is known as the word root. So this 5 carbons are there, and this 5 is the word root for this particular molecule, right? So here you can see what is word root: number of carbon atoms present in the main chain. Later I will come to this point also, actually what is the main chain or the principal chain. So if you have only one carbon in your main chain, then for one carbon, according to the Iupac nomenclature, you will write meth. That means METH, meth is used to write carbon 1, right? And if your compound is having 2 carbons, then you will use eth. For 3 carbons, you will use prop. And if you have the 4 carbons in your compound, then you will use but. And if you have the 5 carbons, as you are having in that case, then your word root would be pent, and for 6 it would be hex, and similarly for 7 it is hept, for 8 it is oct, for 9 it is non, and for 10 it is dec. And you can go through your textbook, right, to learn beyond this C10. However, it is very, very important for each and every chemistry student to know the actually the name of these compounds which contains the from carbon 1 to carbon 10. Please, it is very, very important. So this molecule which I have shown here, it is actually having the 5 carbons. So the word root for this particular molecule is pent, because 5 carbons are there in the main chain. Okay, and after this you can see here I have written this Br here, and along with the Br I have also written the OH in that case, which is attached to this, or which is flanked, actually forming the side chains on this particular main chain, or you can say the principal chain of the compound, which contains the 5 carbons. These bromine and the hydroxyl are forming the side chain. So what are the side chains? Technically, side chain means they are the prefixes. They are generally known as the prefixes. So what I can do for you, I can write here, this is your prefix. Technically it is known as the prefix, and it is also known as the prefix. So whatever you will have in your compound, in your main chain, apart from your principal functional group, all will be treated as the prefixes, right? And after prefixes, you can easily see here what I have shown you. There is a presence of double bond between the carbon 2 and the carbon 3. Double bond is there, and see what type of the bonding is present between the carbon atoms, right, in the main chain. Actually it is the suffix. So here I have written the suffix, and this suffix can be of 2 types. First is the primary suffix. So what is the meaning of the primary suffix? Type of the bond present in the main chain between the carbon atoms. See, single bond will always be there in your compound, right? But apart from this single bond, your compound may have your double bond, it may have the triple bond. Since the carbon is having the valency of 4 only, so it cannot have more than 3 bond in any compound. Please remember, beginners, it is very, very important for you. Okay, so primary suffix means nature of the bond between the carbon atoms, and here your nature is the double bond which is present in the carbon 2 and carbon 3. And when you have the different kinds of the bonds, single, double and triple, then you have to give the different kinds of the name to these primary suffixes. So if you have all the carbon single bond carbons in your compound, then your primary suffix would be ane, A-N-E-ane, right? And if you have say carbon double bond carbon in your compound, right, then you will use ene for this. And if you have the carbon triple bond carbon in the main chain, then you will use ine for this. So this is your alkane, this is your alkene, and this is your alkyne. Okay, so you can remember in that case, if you find all single bonds, then it would be ane. If any 2 carbons having the double bond, then you will use ene, and if your carbons are having triple bond between them, right, then you will use ine for this. So you can see here, if the parent chain, see, main chain, principal chain, or the parent chain, later I will come to that point also, what is the parent chain, right? If the parent chain or the main chain contains 2, 3 or more double bonds, right? Say for example your compound is having the 2 double bond, then you have to use the numerical prefixes in order to explain the 2 double bonds. So what is the numerical prefix for the 2 double bonds? See, for 2 double bonds you will use di. That means if you have the double bond 2 times, then you will write diene. Similarly, if you can see here, if you have the 3 double bonds, then you will use tri, and if you have the 4 double bonds, you will use tetra, and so on, right? It is very, very important. And same is true for the alkyne as well. If you have one triple bond, then it's simply alkyne or ine. If you have two triple bonds, then diine. If you have the three triple bonds, then the triine. So it is very, very important. So I hope you understood well what is the word root in the organic compound and what is the primary suffix and prefixes. I already told you, right? Whatever is present in the main chain, it is fine, because this is forming the principal chain. But apart from this parent chain, rest all things would be the prefixes in your compound. So this OH and Br is actually the prefix, right? So now moving to the next slide. So this is your next slide. It is again a very, very important one. What is the secondary suffix? What is the secondary suffix? Secondary suffix means the functional group present in the molecule. And guys, it is very, very important for you to know that functional group is responsible for the chemical properties of the compound. It is very, very important to know that, right? So how many kinds of the functional groups can be present in your compound? It is very, very important. See, if I go back in the previous page, right, previous slide rather, so this OH is a kind of the functional group which is alcohol, and this is CHO, it is another kind of the functional group which is the aldehyde, right? So either of these two, whether this CHO or OH, they may be treated as the secondary suffix. But remember, this would be decided based on the position in the priority table. For time being, I am telling you that CHO would be the main functional group in that case, and OH would be treated as the side chain or the prefixes, because it is in lower position in the periodic table than your CHO or the aldehyde. So if you are finding little bit difficult to know about the name of the functional group and their sign and their formula, then don't worry about that. After the completion of the lecture, you will be able to understand all the things, right? So secondary suffix means the functional group, and the functional groups are always responsible for the chemical properties. And this is the priority table. And please remember, for beginners, it is very, very important, not only for the beginners, but for every chemist. It is very, very important to learn this priority order strictly. If you have idea about this priority table, only then you will be able to write the correct IUPAC name of the organic compound. This is the priority order. Say for example, first group is the carboxylic acid. That means if your compound is having the various functional group, then the compound would be named as acid, because this acid is at the top position in the priority table. Say for example, your compound is having COOH, your compound is having COOR, your compound is having CHO, your compound is also having the OH. Then your COOH would be the main functional group, and this will dictate the chemical properties of your compound, right? And rest all other groups, they will be treated as the prefixes or the side chain. It is very, very important. And when your carboxylic acid, the formula for the carboxylic acid is the COOH, when it is present in the chain, then the secondary suffix, that means the name of the functional group, would be oic acid. The name of the compound will end with the oic acid. And if it is present as a side chain, then it would be treated as the carboxy. However, you can think then when your carboxylic acid is at the top position in the priority table, then how it can form the side chain? Remember, it will form the side chain, and when it will form the side chain, I will discuss that particular example also. But timing, you should know that when it is treated as a side chain, you will name this COH as the carboxy. When it will be treated as the functional group, principal functional group, then the name of the compound would be the oic acid. And second is the derivative of your acid, which is your acetic anhydride. This is a special case, and in that case, your see this is the very special case. I'll come to the later on this particular acidic nomenclature of the acetic anhydride. Timing, you can skip this one, right? And third very important functional group is the ester, which is again the derivative of this carboxylic acid. What is the meaning of the derivative? See, this is your COOH. When I replace the hydrogen of this carboxylic acid with this R could be your anything. R is your alkyl group, right? It may be your CH3, it may be your C2H5 and all these things, right? So it will be your ester, and when ester is present, then name of the functional group, that is the IUPAC name of the compound, when it is present as the secondary suffix, then the compound name of the compound would end at O8. O8 is the name of the principal functional group when it is treated as the secondary suffix. But when, say, your compound is having this acidic functionality and it is also having the ester functionality, right? Two functionalities, see, two functional groups are there in your compound, carboxylic acid and your ester, then your carboxylic acid would be the main functional group and the name of the compound would be the oic acid, and in that case your ester would be treated as a side chain, and when ester would be treated as a side chain or the prefixes, then the name of this ester is the alkoxycarbonyl. See, if methyl is there, then it would be methoxycarbonyl. If C2H5 is there, then it would be ethoxycarbonyl when this ester is forming the side chain or the prefix, and this will only happen when your compound is having the carboxylic acid or the acetic anhydride, because they are placed at the top at the top of the periodic table, right, compared to this ester. After that, another very important derivative of the acid is the acid halide. So when I replace this OH part of this acid with the halogen, that is COX, then it will form the acid halide. So here I am writing the acid halide, but I am going little bit, see, I am showing this Cl here, and when I will write this Cl, then it would be your acid halide, acid chloride, and when I put the bromine here, it would be your acid bromide, right? Or you can say the acidyl bromide, right? And when your acid halide is there, and when it is the only functional group present in the molecule, then definitely the name of the compound would be oil chloride. Like if you have the two carbons and they are forming this acid halide, then ethanoyl chloride would be the name of the compound. But if your compound is having this acid halide as well as your ester, then your ester would be treated as the main functional group and acid halide would be treated as the prefix. And when the acid halide would be treated as the prefix, then its name would be chloroformyl. It is again very, very important. Say, for example, your compound is having the acid halide functionality, it is also having the ester functionality, it is also having the acid functionality. Then your acid would be the main functional group and the name of the compound would end with this name, oic acid, and your ester and halide would be treated as the side chain or the prefixes, right? And next very important derivative is the acid amide, and the formula of the acid amide is the CONH2. What I have done, I have replaced this OH of the acid with the NH2 to make your acid amide, right? And when only this acid amide is present or this amide functional group is present in your compound, then the name of the compound would be your amide. If see, one carbon is there, you know, for one carbon it would be your methane, and this forming your amide, and this functionality is also there, then it would be methanamide. If two carbons are there, then it would be ethanamide, right? But see, if it is a little bit complex and difficult for you, don't worry about that. Whatever I am telling you, you try to note down the things, or you can take the snapshot of this lecture. Later on, when you will read your book, then you will be able to understand all the things what I am explaining right now here, right? This is very, very important. And after that, your cyanide is there, right? When cyanide is there and it is treated as the side chain, then it is the name of this cyanide is your cyano, right? And when it is treated as the functional group, then its name would be nitrile. This is Le, this is nitrile. Similarly, if your compound is having the aldehyde, right, and the functional group for the aldehyde is the CHO, and when it is forming a side chain or the prefix, then its name would be the formyl. And when it is the only, this aldehyde is the only functional group present in the molecule, then the name of the compound would end as al, right? Like methanol, ethanol, propanol, butanol, etc. Similarly, your compound may have this functionality, which is the ketone, and when ketone is there, then when ketone is present as a side chain, that means when your compound is having the ketone functionality as well as any other functional group which is placed at the top compared to this ketonic group, then this keto would be, or this C double bond O would be treated as a side chain. When this CO would be treated as a side chain, its name would be either keto or oxo. But when your compound is having only this functionality, then the name of the compound would end with -one. Like you are having 3 carbons and you are having the carbonyl functionality in it, then the IUPAC name would be the propanone, right? Later I will to come the detailed nomenclature of the ketone as well. Similarly, if you have the OH functionality, which this is where actually the alcohol, and when this alcohol is present with any of the functional group which are placed at the top position compared to this alcohol, then your alcohol would be the side chain, and other functional group which is placed at the top in the priority table would be treated as the main functional group. It is very, very important. So this example is rather important because this is OH and this is CHO. When this OH is treated as a side chain, then the name of the compound would be the hydroxy, okay, or the name of the prefix would be the hydroxy. And when it is the only functional group present in the molecule, then the name of the compound would be the ol. Like you can see the methanol if you have CH3OH formula, ethanol if you have the C2H5OH formula. But it is very important to note that, see, be careful when you are writing the IUPAC name of the compound, because little change in the spelling will actually change the name of the compound, right? See, some people have the habit of writing this A like O, right? So you'll write all, and all means alcohol here. Your compound is having CHO, but you have a bad habit of writing A like O, then it would become all and your question will wrong. Okay, and similarly you may have the amines. When amine is present as the side chain, then its name is the amino, but when it is the only functional group present in the molecule, then the name of the compound will end with the amine. And then you are having the ether functionality, okay, please remember. So this is your ether functionality, this is O, and either side of the O you have the 2 vacant valencies and you can add 2 groups right onto this one. So when this functionality, this ether functionality is present as the prefixes or as the prefix, then its name would be alkoxy. Like 1 carbon with oxygen, that is methoxy, 2 carbon with the oxygen, that is ethoxy. But when it is the only functional group present in the molecule, then the name of the compound would be the alkoxy alkane. So right now it is very, very important to you to understand these things, and if you find little difficult to understand these things, then believe me, you will be able to solve any kind of the problem after the completion of the lecture. So far I have explained you what is the word root, what is the primary suffix, right, and what is the secondary suffix, which is the functional group, and the priority table. When we consider one functional group as a side chain, when we consider the functional group as a secondary suffix. Okay, when your compound is having only one functional group, then obviously it would be the secondary suffix and you will use these names, right? And when your compound is having more than one functional group, then the functional group which is placed at the top position in the periodic table would be the principal functional group, and the other groups would be treated as the prefixes. So far so good. Now you can see see in the earlier example which I have written here. So you can see here these two are the prefixes, because you know your compound is having this functional group CHO, which is your aldehyde, and this is OH alcohol functionality, but in the priority table this CHO is at the higher position than your alcohol. So this would be the main functional group, and main functional group would be treated as the secondary suffix. The name of the compound would end with the al, and this is the double bond present between the two carbon atoms. This is the primary suffix, right? And these two would be treated as the prefixes or the side chains, and you will write these side chains first, right? So I'm coming to this point again, and 5 carbons are also there, right? And when 5 carbons are there, then the word root would be the 5 in that case. Please remember, okay? And this point is very, very important. See, up to this point actually, up to this point, see, whatever the lecture I'll upload on the IUPAC nomenclature, these 20-minute things I'll add in each and every lecture of IUPAC nomenclature, so that new students will be also able to learn actually what I have explained in the previous lecture. So these 20 minutes will always be there in my every lecture of the IUPAC nomenclature, right? So now the question comes, how we can write the IUPAC nomenclature of this particular compound. So sequence to be followed, or sequence must be followed in order to write the correct IUPAC name of the compound. So if you have this particular example, right, say this, you have this particular example, so what you will write first? So according to the IUPAC, you will always write the prefixes first. So I will say, I have written here prefix and prefixes. More, if only one side chain is there, it is prefix, and more than one side chains are there, then it is prefixes. So you will write the prefixes first, and you will also denote the position of the carbon or the number of the carbon on which actually this prefix is actually resting or is bonding, right? And that position of the carbon would be termed as the locant. So first of all, you will write the prefixes, that mean these two, and their locant, that mean the number of the carbons on which they are forming a bond, or to which they are forming the bond, or on which they are resting, okay? And you will also follow the alphabetical order when you will write the prefixes, right? So your OH is the side chain, so it is hydroxy, which starts with the H, and this is also the side chain, which is bromine. It will start with the bromine, bromo B. So B actually comes first in the alphabetical order. So first of all, you will write the bromo, and after that you will write the hydroxy. So you will always follow the alphabetical order, okay? And then you will write, after the completion of these prefixes, then you will write the word root. Word root means number of carbon atoms present in the main chain of the compound. Once you write the word root, then you will write the primary suffix. Primary suffix means the kind of the bonding. See, it is very, very important when your compound is having double or the triple bond. So you will write immediately after this word root, you will write the primary suffix, and you will also give the locant, or you will also write the locant of this primary suffix, that means on which carbon actually this double bond is going to start, or is this double bond is there, okay? And once you complete with this one, then you left with the functional group only, then you will write the name of the functional group or the secondary suffix. So this is very, very important. This is very, very important for all of you. So I don't know how much you understood, right? But I am believing that you are grasping the things, right? So based on the discussion which I have discussed, right, which I have discussed to you, I'll try to write the IUPAC nomenclature of this one. See, if you find difficult, then don't worry. It is the little difficult compound for the beginners, okay? And later on, you will understand all the things. So how I can write? So first of all, I am giving the number to this carbon chain. So this is your carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, this is carbon 5. And I know lots of the beginners who are watching this video, they are wondering why actually I have started the numbering of this carbon chain from the right hand side. I can start, or say I could start this from this left hand also, but believe me, this is the correct way of writing, of giving the number to the parent chain. Later I will discuss how we generally do these things. right? So I have numbered this one. So first of all, see, now these are the two prefixes. So first of all, I have to write the name of the prefixes. So how I can write the name of the prefixes? See, at 2 position you are having the bromo, so you will write 2 dash bromo. It is very important, guys, please remember, it is very important to note that whenever you are writing the IUPAC nomenclature, then your numeric value and your alphabet must be separated by this dash or the hyphen, whatever you say. So this is 2 bromo because at position number 2 your bromine is there, right? And then again dash 4 dash hydroxy, 4 hydroxy, right? Why? See, at position number 2 you are having the bromine, and the name of the bromine as a side chain would be the bromo because it is negatively charged ligand, and negatively charged ligand, name of the ligand, negatively charged ligand generally ends with the bromo, right? But you can write, see, halogen are always written as bromo, chloro, ido and fluoro, etc. And at the carbon number 4 you are having the OH group as well. It is also the side chain. So 4 hydroxy, when it is treated as the prefix, then its name is the 4 hydroxy. So you have done with this prefix along with the locate. Now you have to write the word, and be careful and see, I have written this B bromo first because alphabetically B comes first, right? And once you're done with this, then you will write the word root. Word root means number of the carbon atoms present in the molecule. So you can see here how many carbon atoms are there in the molecule. Only 5 carbons are there, right? And for 5 carbon, the word root is pent. So I'll write P-E-N-T, pent, connected with this Y, pent. And you can see here at the position number 2, you are having a double bond, right? Then see, you have done this, you have written this word, then you have to write the primary suffix, that is the type of the bonding, especially when it is the double and the triple bond present in the molecule. And of course this molecule is having the double bond between the 2 carbon atoms, so you have to write this primary suffix, right? And you will also write the locant of this primary suffix. So locant is what? That means the carbon from which actually this double bond is starting. So from carbon number 2 it is going to start, right? So you will write dash 2 dash ene. You know, when your double bond is present in the molecule, see, for single bond the suffix is ane, primary suffix is ane. For double bond the primary suffix is ene, E-N-E, and for triple bond primary suffix is ine, Y-N-E. But I'll not write the terminal E here because IUPAC nomenclature says that if you write E here, then you have completed the name of your compound, but the name of the compound is not completed yet because you didn't write this functional group, and you have to write this functional group as well. So I have to write this functional group, and for this, to write this functional group, I'll write this dash 1 dash al. Remember, when aldehyde functionality is there, then the name of the compound would end as the al. I can go back to show you again. You see here, this is my aldehyde functionality, and when it is the main functional group, then the name of the compound would be al, right? That's why it is very important I have written this al here. So this is the complete name of this particular compound: 2 bromo, 4 hydroxy, pent 2 ene, 1 al. See, this A is actually what? Vowel. What are vowels? You know, A, E, I, O, U. When see, please wait, U. So when the name of the principal functional group or the secondary suffix starts with the vowel, then you will not write terminal E here. But when the name of the functional group starts with the consonant other than E, I, O, U, then you will write the terminal E as well here according to the IUPAC nomenclature. But I know for the beginners this example is little bit difficult, right? Because I didn't tell you how to name the compounds having the functional group, right? So I hope up to this point there is no problem, right? Now moving to the next slide. So here you can see IUPAC nomenclature of the alkenes as well as the alkynes, and again we will follow the same rules. So what the rule says, the first rule is the selection of the longest continuous chain of the carbon atom that must contain double bond or triple bond or both if present together. But in this first example you are having only one double bond, there is no question of the triple bond, so we will apply this rule 1 partially to this molecule, because complete scenario or the complete picture is not there in this molecule which includes the double or the triple bond as well, right? So how we can give you the name? So first of all you should number the carbon chain, and the chain must be longest in nature, and it must include your double bond or the triple bond in case the double bond, right? But sometimes guys it may also happen that your compound is having the longest chain, say for example the chain of the 7 carbon atom, right, or the 8 carbon atoms, or other chain say present is of 5 carbon atom, but the necessary condition is that your chain must contain the double bond. If your 5 carbon atom chain carries the double bond, then it would be your principal chain, and if your 7 carbon atom chain is not carrying the double bond, then it will be treated as the side chain. So if I apply that concept here, so I can number this, say this is carbon 1, carbon 2, carbon 3, carbon 4 and carbon 5. So this is 5 carbon atom chain, right? But on the other hand you can see here what I can do here. Say if I start numbering from here, 1, 2, 3, 4, 5, 6. So again this example is quite good here. See, this is the longest chain of the carbon atom, right? But this longest chain is never having your double bond, so it cannot be, the 6 carbon atom cannot be the principal chain or the parent chain in that compound. But if you select this chain 1, 2, 3, 4, 5, then your double bond is present between carbon 1 and carbon 2, this would be your longest chain, right? So what I can do, I can remove the numbering which is wrong here to avoid the confusion. So I am removing this, right? Now you see this part is your prefix or the side chain. This is your prefix or the side chain, and you know while writing the IUPAC nomenclature of the compound, we always write the prefix first along with its locant number. So this ethyl group which is here, it is present at the carbon number 2. So according to the IUPAC nomenclature, I'll write the 2-ethyl, right? This is the prefix. Now you will write the word root. Word root is the total number of the carbon atoms present in the compound. So 5 carbon atoms are there in the compound. So for 5 you will use the word root pent, and this is having the double bond between carbon 1 and carbon 2. So it is always write the primary suffix. Primary suffix means type of the bonding, and whenever this double bond is there, then you will use the primary suffix "ene", right? ENE, ene, and you have to also indicate the position of that double bond, and always you will write the carbon atom from first carbon atom from where you are starting the numbering, right? So here you can see at carbon number 1 you are having double bond, so for double bond you will write "ene". So this is the correct IUPAC nomenclature of this particular compound, 2-ethyl pent 1-ene, right? So selection of the longest continuous chain that must contain the double bond. That's why I have selected this particular chain. I hope this is quite good, right? So while writing the name of the alkene alkyne, the suffix or say for alkane it is the suffix of the ane of the corresponding alkane will be replaced by ene for alkene and yne for the alkyne. Say earlier you have seen in my first lecture that your saturated hydrocarbons having the name which ends with the ane because they are the paraphenes, alkanes, right? And when you have the alkene, then what you have to do? Then the ane of this alkane would be replaced by the ene if your compound is alkene, as I did here, right? But if, say for example, this triple bond was there, then we had to write ine, that is alkyne for that triple bond, right? So again, this point number 2 I have covered in my first example. Now the next very important rule, the rule number 3, right? Here you can see this is my chain and this is another compound. Now this is triply bonded compound. This is your alkyne, this is your alkene. Now I have to select the longest chain of the carbon atom that must contain the double bond. So I am having the 2 options for this. Say this is 1, this is 2, this is 3, this is 4, this is 5. And another option I am having is 1, 2, 3, 4, 5. Both the numbering, both the fashion of the numbering giving the same number of the carbon atoms. But the IUPAC rule says that you will number the, or we have to number the chain, or we will number the carbon atom chain from that end which gives the lowest possible number to the double bond, right? Say for example, I have written here the numbering of the carbon atom in the present chain or in the parent chain or the your principal chain is done in such a way that the carbon atom carrying the multiple bond get the highest priority or the lowest number. Highest priority or the lowest number, they are the same thing. The position of the multiple bond is then indicated by the locant, as I have shown you in the first example, right? And then the multiple bond is then indicated by the locant of the first carbon atom of the multiple bond, right? So as you can see here, if I follow this numbering pattern which starts from the left hand side and goes up to the right hand side, then I am having my double bond at position number 2 and 3, right? Position number 2 and 3. And if I select the numbering, the pattern which starts from the right and goes to the left, then it will give you the position of the double bond at carbon number 3. But the IUPAC nomenclature says that it must have the lowest number or the highest priority, and lowest number is actually 2. So we will select this pattern, white color pattern of numbering, right? The chain, while we will not adopt this thing. So I am removing the wrong thing here, just like that. And now I have to write the nomenclature. There are no prefixes in that case. So first of all, you will write the word root. Word root means total number of the carbon atoms present in the compound. So 5 carbon atoms are there. We will use the pent, and then I'll indicate the position of the double bond, right? This would be your 3 dash, and since it is an alkene, so your ane of alkane would be replaced by ene for the alkenes. So I'll write here pentene. So this is the correct IUPAC nomenclature, pent 3-ene. But right, sorry, not 3-ene, I'm sorry, very sorry. It is starting at the carbon number 2 because I have selected this one. So I have to write this as like that, pent dash 2 dash ene. Now this is the good example. If see, I did a mistake here. If you follow this particular, if you have followed this one and you say for example in your examination this question comes and you will write this pent 3-ene, then obviously it would be wrong. Please remember, it would be wrong because the rule says that the carbon atoms from where actually your double bond is starting, you will indicate that locant position, and that locant position is 2 but not 3. Please remember here, the position of the multiple bond is then indicated by the locant of the first carbon atom of the multiple bond. So this is the multiple bond which is there in the 2 and 3, and that carbon number 2 is the first carbon from where actually a double bond is starting. So the correct IUPAC name is this one, pent-2-ene. So I can write properly 2-ene. Now in the similar pattern, then you have to select the chain here. Say this is carbon 1, carbon 2, carbon 3, carbon 4 and carbon 5. You cannot go in that manner. 1, 2, 3, 4, 5. This would be wrong, because if you followed that numbering pattern, then your triple bond is present at the position number 3, position number 4, right? And when you follow this pattern from right to left, then your triple bond is present at the locate number 1, and IUPAC says that you have to give the lowest possible number to the carbon which carries the multiple bond. So this above one is the correct one and second one is the wrong one. So what would be the IUPAC nomenclature of this particular compound? There are no prefixes in it, so you have to write the word root, and for 5 carbon atoms your word root is pent, right? Dash, then you have to write the primary suffix. Primary suffix means the type of the bonding, which is triple bond here, and it is present at carbon number 1 and 2, and the rule says that you have to write the first carbon atom from where actually your multiple bond is starting. Dash, since it is an alkyne, right? It is an alkyne, then terminal E of the alkane would be replaced by the YNE. Say if you have alkane, then you will write this, and when you have the triply bonded compound, then your ANEane would be replaced by the alkyne, where alk stand for the word root, right? So this is pent-1-ine. This is the correct IUPAC nomenclature for this particular compound. I hope this is quite good. Now moving to the next example, right? These are the two examples. This is example 1, this is example 2, right? In that case, your double bond is present twice. So you have to write di for 2. If this double bond is present 3 times, then you have to write tri for this one, and you will always indicate the carbon atoms of the 2 double bonds, first carbon atoms of the 2 double bonds which are there in your compound. So how I can do the nomenclature? Say this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, and it will not make any difference. Please remember, it will not make any difference if I follow the numbering pattern which starts from the left and goes to the right. Say if I follow this one, see, for beginners it is very, very important. If I follow this one, 1, 2, 3, 4, so it will not make any difference. Why? If you follow this one, then carbon 1 and carbon 3 is actually having the double bond position. If you have followed the numbering from right to left, then again carbon number 1 and carbon number 3 you are having the multiple bond. So now it is a good choice for you whether you can start from the left to right or the right to left. Both will give you the same result, right? Since I need some space, so I am removing this one. How I can write the IUPAC name for this particular compound? How many carbons are there? Because there are no prefixes, so we have to write the word root. 4 carbons are there, and for 4 carbon atoms your word root is but, right? And here I am writing extra A here. Later I'll explain why I'm writing this one, right? And then dash at position number 1, comma, and at position number 3 you are having the 2 double bonds. See, this is position number 1, this is position number 2. You are having the 2 double bond. For 2, since I am having the 2 locants here, so I have to write di for this one, right? Di means 2, so I'll write the di, and these are the alkenes, so I'll write the diene. Now you may have the confusion, especially if you are a beginner, right? Why? Because here I have write only pent, and I have dropped the A from this end, and similarly I have done for this one. I have dropped A from here, but in that case of but, I have write buta. I have retained this terminal A, right? Why? The rule says that when the name of the functional group or the primary suffix starts with the consonant, then you have to write the A here, right? But if the name of this primary suffix or your function group, if it starts with the vowel A, E, I, O, U, then you have to drop the terminal A. So in that case, you see this is E, E is vowel, and rule says that when the name of the primary suffix or the secondary suffix, whatever, right, if it starts with the vowel, then you have to drop the A. That's why I have dropped the A from here, but I have retained this A here because rule says that it is a consonant, then you have to write the A. So correct IUPAC name is buta 1,3 diene. If you write the but 1,3 diene, then it would be wrong. Please remember, it would be wrong, right? Similarly, you are having the next example. Say this is 1, this is 2, this is 3, this is 4, this is 5. So at position number 1 and position number 4, you are having the 2 triple bond. If you follow that numbering pattern 1, 2, 3, 4, again it will not make any difference whether you follow numbering pattern from left to right or right to left. Then what would be the IUPAC name of this particular compound? 5 carbons are there, then you will write pent, right? And again I'll retain the terminal A, right? And I'll indicate the positions of the triple bond which is present at carbon number 1, comma, and carbon number 4 dash di, right? Because this name is starting with the D, which is the consonant, then I have to retain this A, and since these are the alkynes, triple bonds are there, so diene. So the correct IUPAC name is penta 1,4 diene. Whatever I have explained you, I have also summarized here in words. You can take the snapshot if you want. Otherwise, these things are there in your class 11th books, right? Now moving ahead. Now I am having some other examples, right? These are the practice problems which are very, very necessary for the beginners, right? And see, not only for the beginners, even for those teachers or the students, right? They are who are not actually continue in the practice of writing the IUPAC nomenclature, then they can also have the confusion, right? So now what the rule says that, right? So I'll use the rules which I have used in my first lecture as well as the rules which I have explained in this particular lecture, right? I am having the ways of numbering it, right? So I can write 1, 2, 3, 4. This is the one way of selecting the chain, right? If I select this one, right? And say for example, this is what 4 carbon atom chain. This is 4 carbon atom chain. Okay. But if you follow this one, say for example, 1, 2, 3, 4 and 5. This is 5 carbon atom. And if you select this, see, if you select this chain, 5 carbon atom. If you select this chain, again 5 carbon atoms are there. But these two cannot be the principal chain because they are not having the 2 carbon atoms which are bonded by a double bond or the multiple bond. So this is wrong. If you select this chain, this is wrong. If you select this chain, again this would be wrong. So when they are wrong, then I can remove I can quickly remove this, right? So I am removing this numbering pattern. Now you are having another things here. This is your methyl, right? And this is your ethyl. Okay. So how I can write the IUPAC nomenclature of this one? The rule says that you have to write the prefixes first in the alphabetical order, And you know, this is your CH3, this is your methyl, okay? And this is your C2H5, this is your ethyl. Alphabetically, this E comes first. So I have to write this first 2-ethyl. Right? This is your first prefix, and then at position number 3 you are having another prefix which is your methyl, and it is customary to separate the alphabet and the numeric value with this dash or the hyphen, right? It is there in the IUPAC nomenclature. So I have written the name of this ethyl along with its locates, this is 2-ethyl, and again I have written this side chain which is methyl along with its locate, that is 3-methyl. These things are now finished, or I have compiled. Now you have to write the word root. How many carbons are there? So 4 carbons are there. You will write but, and at position number 1 you are having double bond, so you will write ene for the double bond. Since the name of this compound is starting with the vowel, so I have to drop the A here. So correct IUPAC nomenclature for this particular compound is 2-ethyl 3-methyl but 1-ene. And again, it is very important. See, you may write butene 1 or you may write 1-butene, but 1-butene would be entirely wrong, and butene 1 is okay, but the IUPAC nomenclature says that it is a very good practice. According to the IUPAC nomenclature, you have to write the locant of that double bond between the word root and the primary suffix. This is the word root, this is the primary suffix. Primary suffix means type of the bonding. So whenever your multiple bond is present, then you have to write its locant between the word root and the primary suffix according to the IUPAC nomenclature. So this is the more correct way of writing the IUPAC nomenclature. However, it would be quite okay if you write like that: 2-ethyl, okay, dash 3-methyl, okay, and then butene 1. This is also correct, but this is the best way of writing, okay, right? Now moving to the next problem, what it says that, see, for example, I'm going to solve this particular example, okay. Again, you see, this is the multiple bond, and you have to include that multiple bond in the main chain or the principal chain, right? And you will also number the chain in that manner which gives the highest priority or the lowest possible number to the carbon which carries the multiple bond. So in the light of these two rules, I have to write 1, 2, 3, 4, 5, 6. Total 6 carbons are there. Okay. Now, when you follow this one, then this is your side chain. Please focus on this particular example. I will explain another things here. And this is your next. Now, alphabetically, you know, ethyl E comes first. So you'll write 4-ethyl. There is no problem, because this ethyl is present or connected with the carbon number 4, and this methyl is also connected with the carbon number 4. So dash 4 dash methyl, right? So this is the correct way. You cannot write that 4, ethyl methyl. This would be wrong. You have to write the different kinds of the prefixes along with the following the alphabetical order, right? And that's why I have written this 4-ethyl 4-methyl, right? And how many carbons are there in the main chain which gives the word root? 6 carbons are there. So I'll write hex here, and at the position number 1 you are having the ine, right? Right, hexine, right? So again, since it is starting with the Y, so pronunciation is like that. I, pronunciation is like I. However, it is not, see, A, E, I, O, they are your vowels, right? Please remember. But this Y is not vowel. But when you pronounce this alkyne, so it pronounced like I. So we will not include terminal A here. We will drop this for Y as well. So 4-ethyl 4-methyl hex 1-ine is the correct IUPAC nomenclature of this one. Now you, if you are following this lecture very closely, then you may have some other options to write the IUPAC name of this one. Say, if you have followed this chain, 1, 2, 3, 4, and say this is 5 and this is 6, right? If you have followed this one, if you are following this one, so this is also correct. Why also correct? Again at position number 4 you are having ethyl, and again at position number 4 you are having at this methyl if you follow this particular chain. So whether you select this principal chain or that principal chain, this will not make any difference, guys. Okay, that's why both the way would be the correct one. Now moving to the next example, which is this one. Now again, see, you have two choices. Say 1, 2, 3, 4. This is one way. Now this is 1, this is 2, and this is 3, this is 4. See, earlier in case of the alkanes, you have seen we always number the chain in from that end, which gives the prefixes highest priority or the lowest number, and that highest priority or the lowest number is possible here for this methyl, which is 2. But if you follow that one, it is 3. But please remember, IUPAC says that when multiple bonds, double bond and triple bonds are there, then you will not give the highest priority or the lowest possible number to the prefixes. You will always give the priority to triple bond. So we will select this chain, right, as the correct chain, and we will not select this chain. Please remember, this is again very, very important. And now you have to write the IUPAC name for this particular compound. At position number 3, you are having side chain. So you will write 3-methyl. There is no problem in that. And then the word root, 4 carbons are there. But dash. At one position, you are having ine. So butyne. Right? Again, you see terminal A is not there because this Y is pronouncing like I. Right? So this is the correct IUPAC name of this particular compound, 3-methyl-but1-ine. Now moving to the next problem, which is this one. Now it is quite easy how to do, right? So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. 6 carbon atom chain is there, right? This is one way. But if you follow this chain, say 1, 2, 3, 4, 5, 6. This is another chain. But in both the cases, right, whether you select this long chain, this is one side chain, this is another side chain, this is another side chain. 3 methyls are there if you select this particular chain. But if you select this particular chain, so again, methyl and methyl, 2 methyls are here, which are at position 5, sorry, and methyl, which is there at position number 4. So whether you select this chain or you select this chain, it will not make any difference. Both are correct. And then you will write the IUPAC name of this compound. So you have to write the prefixes or the side chain first. This is prefix. Let's say this is another prefix. This is another prefix. Both all are same kinds, right? And when you have the same kinds of the prefixes, then you have to write their locants first. Say 4, 5, 5, because at 5 carbon atom it is present twice. Okay, it doesn't matter whether you select this chain or that chain, right? Since all are same, all side chains are same, so we can straightforward write tri. Okay, and then we will write the methyl. This is your trimethyl. Now you will write the word root for this one. Word root means total number of the carbon atoms. 6 carbon atoms are there. For 6, your word root is hex. Okay. And at position number 2, you are having double bond. So you write the hex 2-ene, right? Again, I have dropped the A from here. So correct IUPAC nomenclature for this compound is 4, 5, 5 trimethyl hex 2-ene. Now moving to the next problem. Now this is again the very, very important one. Very important rule. Again, I am going to summarize here. See. Now say for example, you are having that one, the first one I am doing here. So here in that case, you are having two choices. Very important, guys. You can number this from right to left. 1, 2, 3, 4 and 5. This is one way. Or now the problem is little bit tricky. So you may think that this is also correct. Now when this happens, what the rule says that? Rule says that when you have the double bond and the triple bond both present in the compound, then your compound would be the derivative of the alkyne. Derivative of the alkyne means the IUPAC nomenclature or IUPAC name or the secondary suffix would be alkyne in that case, right? While this would be treated as the primary suffix. That means your compound would be alkyne and that would be your primary suffix in that case, right? Now again there is a problem. From where you will start? See, now you have a choice. You have to start from here, right to left, or you have a choice to to select the chain from left to right. Now the problem is that which one we select. So IUPAC rule says that whenever you have a choice of giving the lowest possible number to the multiple bond, then you will always give the lowest possible number to the double bond. not to the triple bond, right? Whenever you have a choice, please remember, whenever you have a choice. When you don't have a choice, then you will follow the lowest set of locate rule. I'll come to that again, right? So in the light of this particular rule, I have to remove this numbering pattern. Why? Because this numbering pattern is giving the highest priority or the lowest number to this triple bond, but IUPAC says that whenever you have the choice, then you have to give the priority to the double bond. So this is the correct way, right? So now how I write the IUPAC nomenclature of this compound? How many carbons are there? 5 carbons are there, so you will write pent. And at position number 1, you are having ene, right? You are having ene, and please remember, I will not write the terminal E here. If I write the terminal E here, then your name is completed, right? When the name is completed, how you can include the triple bond here, right? So to include that nature of the triple bond in the IUPAC name, I have to drop this terminal E, right? And then dash at position number 4, you are having ine, 4-ine. So the correct IUPAC name is what? Pent dash 1 dash ene dash 4-ine. This is the correct IUPAC nomenclature, right? Now this is, I hope this is quite clear to you. Please remember, whenever you have the double and triple bond both together, then a compound would be the alkyne, and that double bond would be treated as the your primary suffix. And whenever you have a choice of numbering, then you will give the lowest possible number or the highest priority to the double bond, not to the triple bond. When you don't have a choice, then you will follow the lowest set of the locate rule. Okay, I hope this is quite clear to you, right? So I have written this example twice, right? Not twice, this is something different. This is the different example. So how I can number this one? Now suppose I follow this pattern. 1, 2, 3, 4, 5, 6. So if I follow this pattern of numbering from right to left, then at position number 1 and position number 3, you are in position number 5, you are having the multiple bond. So what it is coming actually? What it is coming? 1, 3 and 5. Okay. But say for example, I follow this one. 1, 2, 3, 4, 5 and 6. If I follow this one, then your position number 3 and position number 5 is having double bond, which is against the highest priority rule. So you cannot select that particular chain. Okay, you cannot select that particular chain. When we are not selecting this chain, so it is my duty to remove this thing from here. So how you can write the IUPAC nomenclature of this compound? Now this is very important. So how many carbons are there? 6 carbons are there. So you will write hex for this one. There is no problem in that. Okay. And then you are having, how many double bonds are there? One double bond at position 1 and other at position 3. So you will write hexa because they will start with the di now. 1 dash 1 comma 3 comma di ene, right? And at position number 5 you are having ine. This is the correct name. Hexa 1 comma 3 di ene 5 ine is the correct IUPAC nomenclature for this particular compound. I hope this is quite clear to you. Now moving to the next problem, what it says. Now this is the next problem or the similar problem. 1, 2, 3, 1. Okay, these two problems are same. Somehow I have written same, right? So these two are same and I'm not going to solve this one. Now you see this one. Now again, this example is quite important. Please listen, this example is quite important for you. Why this is quite important? Let's check. Say this is 1, this is 2, this is 3, this is 4, this is 5. You are selecting this one. Say for example, you are selecting this one. When you select this numbering pattern from right to left, then at position number 2 you are having the double bond, and at position number 4 you are having the triple bond. Okay, there is no problem in that. That means your locate set is what in that case? 2, 3. This is the locate set. But if you follow this pattern, 1, 2, 3, 4, 5. Then you are having locant set of 1, 3, and this 1 is lower than 2. So here in that case you will not give the priority to the double bond, you will give the priority to the triple bond, because you have to follow the lowest set of locants rule. This is the lowest set of locant, because this one is smaller than 2, right? So you will select this numbering pattern. Here you are not giving the highest priority or the lowest number to the double bond, because it is violating the lowest set of the locant rule. Okay, so now we have to write the IUPAC nomenclature for this one, right? So how I can write? How many carbons are there? Pent, 5 carbons are there, and at position number 3 you are having the double bond, that is pent 3-ene. Then dash, at position number 4 you are having the ine. This is the correct IUPAC name of this particular compound. Pent 4-ene 1, pent 3, 1, 2, 3. Yes, pent 3, 1 ine. Right. This is the correct way of writing the IUPAC nomenclature of this compound. I hope this is quite clear to you. There is no problem in that. Now moving to the next problem. Okay, see, I have explained all the examples. So whatever I have explained here, I have also summarized here. If the parent chain contains both double and the triple bonds, then the terminal E in the name of the alkene is dropped. It is followed by the suffix beginning with the vowels A, E, I, O, U, right? When your suffix is starting with this one, I have explained this you. Number as low as possible are given to the double bonds or the triple bond as a set, even though this may at times give the ine the lower number or ene, right? Then ene. However, if a choice is there, preference for the lower locant is given to the double bond. If choice is there, here you are having the choice, right? But in that case, you are not having the choice. You have to select the lowest possible number. These compounds are named as the derivative of the alkynes rather than the alkenes. That means the name of the compounds ends with the alkyne if you have the double and the triple bond both in the compound. I hope this is quite clear. Now moving to these are the some of the practice problems. Now these are the quite simple and the easy things, and you see, I'll not solve all the problems, right? Or I say I'm solving this problem, but very quickly. Now you have, what are the rules here? Say 1, 2, 3, 4, 5. And this is your side chain which is present at the position number 3. So this is your 3-methyl, okay? And 5 carbons are there, so you will write the pent, okay? And you will write the terminal E as well, because at position number 3 and at position number 4 you are having diine. So this name is starting with the consonant, so you have to write A here. Since 2 locants are there at the carbon number 1 and carbon 3, you are having the primary suffixes, so you will write the di for this one, ine. So this is your 3-methyl penta 1, 4 diene. Now moving to the next one very quickly. Say now again this example is important, very important. Say you are having this 1, 2, 3, 4, right? And this is your side chain. Okay, so what would be the name? 3-methyl. There is no problem in that. How many carbons are there? 4 carbons are there. You will write but. Terminal A would be there, and at position number 1 and position number 3 you are having the diene. I hope this is clear. 3-methyl buta 1, 3 diene. If you write the name like that, then boss, this would be wrong. Why? I am giving you the little more insight to this particular example. Say I am starting numbering from here 1, 2, 3, 4. When I do this, then this methyl is present at position number 2. It is connected with the carbon number 2. Then what would be the name? I am writing with the blue 2-methyl buta 1, 3 diene. See, there is no change in the locant of the diene, but again, see, lowest possible number I am giving to the side chain as well. So this is the lowest set of locant, which is 2, 1 and 3. Here is 3, 1, 3, which is not the correct one. So the correct IUPAC name of this compound is the 2-methyl buta 1,3 diene. This is the correct one. Now this is your next problem, right? Say here, say this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. How many carbons are there? 6. So you write hex and you will write the A here, right? And at position number 1 and at position number 3 you are having ene. 2 locants I am using, so this is di, right? This is a trick. And you will write the ene, terminal E will be dropped from here. Why? Because I have to write the complete IUPAC nomenclature of the compound. If I write E here, then the name completes. Then how I can include this one? So the correct way is to drop the terminal E from here. Okay. And then at position number 5 you are having ine. So this is the correct way or correct way of writing this one. Hexa 1,3 diene 5 ine is the correct IUPAC nomenclature. Okay. Now moving to the next one. Right. Now again, important things are coming here. Sometimes, guys, it may happen that you cannot include all the double bonds in the chain. Then one of the double bond would be treated as the prefixes, right? And others would be treated as the primary suffixes. In some cases, all the double and the triple bonds of the molecule cannot be included in the longest chain due to the complexity of the molecule, right? In such cases, the following prefixes are used for the double and the triple bonds, right? Groups acting as the prefixes or the side chain. See, if this double bond CH2 is your side chain, then you will use the methylene. The name of the prefix is the methylene. So I am writing prefixes here. So, prefixes. Okay, so these are the prefixes basically. Just like that. Okay. So please remember, when you have this double bond CH2 as side chain, this is methylene. When you have the CH3 double bond, it is ethylidene. When you have the CH double bond CH2, that is, it is vinyl. More commonly vinyl, but you may also write the ethinyl, vinyl or ethinyl. But I will follow the vinyl, right? You can also write the ethinyl. Okay. And then this triple bond C, that is your ethinyl prefixes. So keeping these things in the mind, I can solve a new problem, which is this one. Say this is 1, this is 2, this is 3, this is 4, this is 5. This is 5. I am selecting this chain, right? However, you can select this chain as well. This will not make any difference. If I select this one, 1, 2, 3, 4, 5. This will not make any difference. You can select either one. Okay. Now you are clearly observing that this is not included in the main chain. This is the side chain. So basically, this is what? This is your methylene. Okay. When this is methylene, so this is a side chain. This double bond is the methylene prefix. And according to the IUPAC nomenclature, we have to write the prefixes first. It is connected with the carbon number 3. So I'll write the 3-methylene. 3-methylene. There is no problem in that. Okay. And then what root I have to write? 5 carbons are there. For 5, pent is used. Since it is a diene, so I'll write the terminal E here. At position number 1 and position number 4, you are having the diene. So I'll write like that. So the correct IUPAC name for this compound is the 3-methyl penta 1,4 diene. I hope this is clear. Now the next problem, how I can solve this one? See, obviously I will select that chain which include maximum number of the double and the triple bond, or the length of that chain must be longer. Say now, initially I am giving you some hint how you can go wrong. Say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. This is 6 carbon atom chain which is including this double bond and this double bond. But if you follow this one, this would be wrong. Why wrong? Because this is 5, this is 6, this is 7, this is 8. So here 8 carbon atom chain is there, and on this chain you are having double as well as the triple bond. It is not necessary that you will always include the two double bonds and leave this triple bond as it is. No, 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 no. Whenever you have this double bond and triple bond in the compound together, then you have to select the longest continuous chain which includes the maximum number of the double or triple bond. Not necessarily both double bond, not necessarily both triple bonds, one triple, one double would be quite good here. So according to this rule, this I can remove from here. So this is the longest chain of the carbon atom which is having the double bond and the triple bond. Now this is your side chain which is prefix, starts with the M. This is methyl, there is no problem. And again this is CH double bond CH2, and this is your what? This is your vinyl, or you can write ethinyl, right? This is something very, very important, right? If see, ethinyl is the correct name, not vinyl. Ethinyl is the correct name. Please remember, ethinyl is the correct name. If you use the vinyl, then what will happen? You will write the M first, right? And that would be wrong. So correct way of writing IUPAC name is that at position number 4-ethinyl, right? 4-ethinyl. I'm writing in that manner. -3-methyl. No problem in that. 8 carbons are there, so what would be oct. At position number 1 you are having ene, and at position number 6 you are having ine. Okay, so 4-ethinyl, 3-methyl, oct 1-ene, 6-ine is the correct name. But if you write vinyl, which is not the IUPAC thing here, so you will write like that. At position number, then you will write what? Alphabetic. If you follow the alphabetical order, then you will write this first. 3-methyl, okay, and then 4-vinyl. Rest thing would be same. And this gives you the little ambiguity. So according to me, that one is the more correct one. However, if you write this one, some examiner, it depends on the examiner, they may mark this answer as the correct one or the wrong one. But if when it comes to the JEE examination or the CSIR net or the GATE examination, then this would be the best choice. Please remember, this would be the best choice. Now moving to the next thing. Now these are some of the practice problems, right? You have tried the practice. You have to do the practice for this one. So how I can give the name to this particular compound? Again, you see, I'm having the choice 1, 2, 3, 4, 5, 6, 7. Okay, so this is a side chain. And what is this side chain? It is your vinyl, okay, or ethinyl. So position 5, look at 5, and it is what? Ethinyl. What would is 7? That is hept. For 7 hept we will use, okay, dash. At position number 1 and position number 3 you are having diene, and at position number 6 you are having ine, 6-ine. So the correct IUPAC name is what? If you think 5-ethinyl, hept 1,3, okay, diene, and 6-ine. This is the correct IUPAC name of this particular compound. This is something very, very important, right? Very important, this one. So this is how you can do the numbering. But again, you see, you may have another option as well. Let us check what is another option available for me. Say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. If I follow that blue numbering, so what I am having here, when I follow this one, then this would become what? My side chain. and this C triple bond CH in the side chain, what is the name of this one? Ethynyl. Ethynyl. So I have to write, if I select this blue chain, 3-ethynyl. There is no problem in that. Okay. How many carbons are there again? 6. Hept. Okay. And at position number, not hept, it should be hepta. At position number 1, you are having double bond. And at position number 4, you are having the double bond. And at position number 6, you are having the double bond. Right. Then the name would be heptatriene. Now this is the big problem. This is the big problem. Which is the correct one and which is not the correct one. Okay. So this is one way of writing. Now, is there another way of writing this IUPAC name for this particular compound? 1, 2, 3. Let us check whether another possibility is there or not. 1, 3, 6. Okay. See, this is another way. Now I am using the white numbering pattern. 1, 2, 3, 4, 5, 6, 7. Now I am following the white pattern, and please follow the white pattern here. So if I follow that white pattern here, so in the white numbering, at position number 5, you are having this ethynyl. At position number 5, we are having this ethynyl, which is this one. Okay. Right. And right. So you will write for this one, say I am writing here 5-ethynyl. This is the side chain now. Okay. How many carbons are there again? 7 carbon atom. Hept. That is hepta. Now the positions of the double bond at 1 and at 3 and at 6. 1, 3, 6. Okay. So 1, 3, 6 triene. Right. This is another name. So we are having the 3 possibilities. One is this one, another is this one, and next is this one. What the rule says that which one is actually the correct one here. See, this is 1, 4, 6 and this is 1, 3, 6. So this is lowest set of locant, but this is not a lowest set of locant. Okay. So this cannot be correct in the light of the lowest set of locant rule. Now there is a competition between the two, whether we write ine or ene. Earlier I said that whenever you have the double and triple bond all together, then this compound would be named as the alkyne. But in that case the things are quite different. Why? Because your longest chain of the carbon atom is having 3 double bond in the main chain, and when this happens, you will always give the priority to the double bond, not to the triple bond. Please remember, you will always give the priority to this one. When you give the priority to the double bond, then this would be your correct one, and this is not. This was the very beautiful example, right? So this is the correct example. I hope this is quite correct to you, right? Very special example, right? Now, moving to the next one. And that next one is this one. Not this one actually, they both are same actually. They both are same. Okay, they both are same. Now, let's do some more practice. Write the structural formula for this compound. See, so far what we did actually, we see the structure, we observe the structure and write the name. But now the things we'll do the differently. because you may have the question of this kind. You may have the name of IUPAC name of the compound in the examination, and you have to write the structure, whether in the condensed formula or the expanded or the bond line notation, whatever. Right? So I am writing the condensed one for this one. Condensed formula where you will not show the bond, any bond, right? So please remember, say for example, this is your CH3, this is your CH3, okay, or this one, say this is CH3, this is CH3, this is your condensed formula, condensed, okay, because bonds are not shown. And when you show the bond, this double bond, then this is your expanded form. Expanded form, or in the expanded form you can do this thing, H, 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 H and H. This is extended, right? And when you write this is bond line. This is bond line notation. In bond line notation, when this is there, then terminal, basically two terminals are the two carbons. So you write the two carbons, and then you have to complete the valencies, because carbon is tetravalent. So one valency is this one, 3 is this one, 3 and 1 4, 3 and 1 4. So condensed formula, expanded formula, or scattered formula, or bond line notation, you need to know all the things, right? So I am removing this thing. I hope this is clear to you, because we will also solve the problems of your bond line notation. So how I can write this one? So the important thing is that whenever you have say for you have given this particular name, then you have to draw a structure. Select the word root first. So 5 carbons are, pent is there, that means 5 carbons are there. Write 5 carbon atoms, okay, and randomly from any end you can give numbering to this one. So for example, this is 1, this is 2, this is 3, this is 4, this is 5, okay. Now you see at position number 4 you are having methyl, so straightforward you will write methyl here. And at position number 2 you are having the double bond, right? And you know, you will also always indicate that carbon which actually having the multiple bond, which, from where actually the multiple bond is starting, right? Otherwise you can put double bond here and it will represent between 1 and 2, then it would be 1 ene, so it is 2. Now that's why I have put it here. This is pent-2-ene. Now connect all the carbons with the single bond, 1 2 3. Now you need to complete the valencies. Carbon is tetravalent, so this is carbon, 1 valency is there, so 3 valencies with the 3 hydrogens, 3 1 4. And here in that case you see 1 2 and 3, only 3 valencies are there, so I'll write the CH. Again you see this carbon, 1 2 3, 4th valency with this hydrogen, and another you see this hydrogen, and then you have to write the CH3. Let's check. 3 plus 1 4, 1 2 3 and 4th is the hydrogen, 1 2 3 and 4th is the hydrogen, 1 2 3 and 4th is the hydrogen, 3 and 4. This is how you can write the name. Now say you are having this one, so how you can write? Pent, 5 carbons are there, 1 2 3 4 5. Number from any end, say 1 2 3 4 5. And at position number 2 you are having the ethyl, so you'll write C2H5, no problem in that. And at position number 2 you are also having double bond, put the double bond here. Connect all the carbons with the single bond and complete the valency. CH3 CH2 CH CH3, because this carbon has the completed valency, right? 1 2 3 and 4. This is how you can write the IUPAC name. Now these are the some of the practice problems, right? So these are the simplest practice problem. You can do this by your own. See, try to write the name of this particular for these compounds, which actually I am not solving here, and comment in the comment section. Write the comment what actually answer you are getting. I'll reply whether you are answering correct or not. Same is true for this one as well. Okay, you will try to do this one, and same is for this one and this one, right? But this example is quite unique, so I'm going to solve this example. This example is unique. Wherever you have such situations, so what you will do here, carbon double bond carbon, no problem. And you know this carbon is having C2H5 two times. What is the meaning of this? You are having C2H5 here, okay, and again you are having C2H5. Any problem? No. Similarly, this carbon is having C2H5 and this carbon is also having C2H5. Basically, you have expanded. This is your condensed formula. You have expanded this one, partially condensed because double bond is there, okay, and you have expanded this one. Now the picture is not completed yet. This C2H5, this one, this one, this one, or that one, you may write like that, CH3 CH2. This is your ethyl, which is this one. This ethyl you can, C2H5 you can write like that, na? And then your carbon, then again you can write CH2 and CH3 for this, okay, and then you are having the double bond between the two carbon atoms, okay, and then you are having what, CH2 CH3, no problem in that, this ethyl group, and another ethyl group is also present on this particular carbon atom. So I'm writing it here, CH2 CH3. Now what you have to do, you have to select the longest chain of the carbon atom, longest continuous chain of the carbon atom. This example is very, very important, right? So how I can select the longest chain of the carbon atom? It's quite easy now. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So 6 carbon atom chain I am selecting this one. Okay, this is your side chain and this is your side chain. 2 side chains are there. That means 2 ethyls are there, which are present in the position 3 and the position 4. 3, 4 dash. Di ethyl, no problem. What root is hex? At position number 3 you are having double bond. Okay, 3, 4 di ethyl hexane, right? Fine, this is quite good now. So this is the correct IUPAC nomenclature of this one. Now moving to the next one. Okay, now some bond line notations we are practicing, some bond line notations. Okay, how I can select the chain. So for this one you have to select the chain and you will apply all the rule. You have to give the lowest possible number to this double bond, and simultaneously you have to select the longest chain of the carbon atoms, and you have to also follow your lowest set of locant rule. Say if you select this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in that case, at 6 and 7 you are having the double bond, okay, and at position number 8 you are having the methyl. This is one way. But if I select this one, say for example I select this one, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, right? If I select this one, so when I select the blue numbering, then at position number 4 and 5 you are having the double bond. That means blue numbering is correct one. So now I am quickly removing all the things and write the correct way, right? So blue numbering I am following. Say this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4, this is carbon 5, this is 6, this is 7, this is 8, this is 9 and this is 10. Total 10 carbons are there. Okay. and at position number 3 you are having methyl, and at position number 5 you are having ethyl. This one carbon is here, this is ethyl. When you write one single line, this is methyl. When two lines, this is ethyl. When three lines, this is propyl. Please remember. Okay, so this is ethyl and this one is ethyl as well. Now I have to write, see what the rule says, that you have to write the IUPAC nomenclature of the side chains first, right? So ethyl, methyls both are there in that case, and you know the E comes first. So how I can write the IUPAC name of this compound? 5,6 diethyl, okay, dash 3 dash methyl. So side chains are completed now. Now the word root, 10 carbons are there, so you will write the deck, and at position number 4 you are having the double bond, that means ene. This is the correct IUPAC name of this particular compound. 5,6 diethyl, at position 5 ethyl, position 6 ethyl. At position number 3 you are having the methyl, deck 4 ene. You cannot say that this this M is C. You will never include this D here, right? Always focus on this one. Otherwise you can skip this because this problem is not including that thing which just I have explained a few seconds ago. This one, D or M. This is not making any difference, because E in the alphabetical order, E comes first and D also comes first. So this is the correct IUPAC name of the compound. Now moving to the next one, say this one. So how I can name this? Say this is one. See, this is chlorine, side chain, and this is C6H5. C6H5 is nothing. It is a benzene ring as the side chain, right? So this is 1, 2, 3, and right, 3 carbons are there, and this is phenyl, okay, and this is chlorine, chloro, right? 2 things are there in that case, okay. And when this happens, so you have to write, you have to follow the alphabetical order, and when you are following the alphabetical order, then at position number 1, or say, see you cannot, or again I did a mistake here, you see, I have selected this chain 1, 2, 3, which gives the lowest possible number to this double bond is 2, which is quite wrong. It is not following the lowest set of locate rule. So now the focus on this white numbering, 1, 2, 3. Now it is quite good. This is the correct way of numbering. This is not. Okay. So at position number 3 you are having the chlorine. So this is your 3 chloro. And at position number 1 you are having another side chain, which is your phenyl, that is 1 phenyl. There is no problem in that. And for word root, 3 carbons are there, so you'll write the prop. And position number 1 is having your alkene, that is propene. So 3 chloro, 1 phenyl, prop, 1 ene is the correct IUPAC nomenclature for this one. Similarly, say this one, 1, 2, 3, 4, 5. So at position number 5 we are having the bromine, so you will write the 5 bromo. 5 carbons are there, so you will write the pent. At position number 2 you are having the alkene, that is pentene, 2 pentene 2. So again you are giving the preference or the lowest possible number to the double bond, but not to the Br. I hope this is quite clear to you. Similarly, you can solve this particular example. Try to write the answer and comment in the comment section whether you are getting correct or not. Now this is another your bond line notation, which is quite important for you, which is very, very important. How I can select this one? See, there are 2 ways, but I am not explaining you the simplest way. I am explaining you the difficult way. That means assigning name as such, not converting this into the proper carbon hydrogen formula. So here you can see, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is 4, this is 5, this is 6, this is 7, this is 8. Or if you follow another numbering, say white one, 5, 6, 7, 8. So this will not make any difference. So you can select either way. I am selecting this one, right? I have selected this one. So at position number 5 you are having side chain 1, 2, Three carbon atom side chain you are having here, which is what? 5-propyl. 5-propyl, right? 5 propyl. Total 8 carbons are there. You write the oct for this one. And at position number 2, you are having the triple bond, that is oct-2-ine. This is how you can write. Okay. Otherwise, you can convert this into the simplest formula. How? 8 carbons are there, so you can write 8 carbons. Straightforward. 1, 2, 3, 4, 5, 6, 7, 8 carbons. Okay. And number the chain from either end, right? And at position number 2, put your triple bond, and at position number 5, put your C2H5. Okay, and connect all the carbons with the single bonds, and then complete the valency. CH3, CH2, CH2. This is CH. This is CH2. Now these two are the same. So I hope this is quite clear to you, right? Now, a few more practice problems. So I am doing 1 or 2 for you, and then you will do by your own. Say this one, but is there. So 4 carbons you will write. Number from any end, 1, 2, 3, 4. 1 and 2 position is having methyl. So put methyl over there, right? And after that, at position number 1 and 3, dienes are there. So double bond here and double bond here. Connect with a single bond this one. This would be your CH2, right? This would be your CH2. This would be your CH. This would be your CH. Okay. This is how you can write. Similarly, say you are having this one. What would is what? Hex. 1, 2, 3, 4, 5, 6. Number from either end. 1, 2, 3, 4, 5 and 6. Okay. And position number 1, 3 and 5, you are having that triene. That means double bond. So position 1, position 3 and position 5. Rest carbon you will connect with the single bond and then complete the valency with the hydrogen CH2. This is CH2 again. This is CH. This is CH. This is CH. This is CH. This is the correct way. Similarly, you can practice these two as well. Now, another examples, right? This I have done earlier, so I am not doing this one. Now I am starting the cycloalkanes. This is something very, very important, right? So again, the selection of the longest continuous chain that must contain the multiple bond. This is the basic rule which you have to follow. Okay. And when you follow this one, so this is 1, 2, 3. This is correct way because you have to give the lowest possible number to the double bond. You cannot do numbering in that manner, right? 1, 2, 3. If you follow this white pattern from left to right, this would be wrong. Okay, so I am not writing this one. And at position number 3, you are having this side chain, which is what? 3 carbon atom. 1, 2, 3. 3 carbon atom cycloalkane. So 3 cyclo. Since it is a side chain like alkyl group, so it is a propyl. 3 cyclopropyl, and in the word root 3 carbons are there. You will add the prop, and at position number 1 you are having the ene. This is the correct IUPAC name of this compound. Similarly, this is your 1 carbon only, and these two are the side chains. So 1, 1 dash dicyclopropyl, and this is the methane, derivative of the methane. This is the correct IUPAC name of this compound. Now this one is this may be a little tricky. How actually we can give name to this particular compound, right? So I am having the choice. Say I am selecting this one. 1, 2, 3, 4, 5. Right? At position number 3, you are having this kind of thing. That means 2 carbons, 1 and 2. That means this is your ethyl. Okay? And this is your 1 carbon thing, which is your methyl. In the alphabetical order, you have to write the ethyl first, because this double bond is inside the ring, so your compound is the cycloalkene. It is not like that. See, earlier one, your double bond is exocyclic outside the ring. Here your double bond is endocyclic inside the ring. When it is inside the ring, then your compound is the cycloalkene. When it is outside the ring, then this would be treated as the side chain. So how I can give name to this particular compound? 3-ethyl, there is no problem in that. -2-methyl, again the same thing. And then because it is a cyclic compound, I'll write the cyclo. 5 carbons are there, I'll write the pent, right? At position number 1, you are having the double bond, so I'll write the ene. So the correct IUPAC name of this compound is what? 3-ethyl 2-methyl cyclopent 1-ene. This is one way of writing IUPAC nomenclature, right? But I am having little doubt. So when I am having little doubt, so I'll draw this again. Okay, this is double bond, this is this, and this is your ethyl, right? Say this is this one. I have written in that manner. Now I am doing the things little differently. Say you may think in that manner that you may number this one 1, 2, 3, but this would be wrong because you are not including this double bond. Okay, so this cannot be done. So this is 2, 3, 4, 5. That means this one is correct one, right? So 1, 2. You have to write. You have to follow the lowest set of locant rule. So this is the correct one. Now this one is quite fine. 1, 2, 3, 4, 5, 6. There is no problem in that. Okay. Why there is no problem in that? Because at 3 position you are having the NO2 group. This is 3-nitro. Okay. And it is a cyclic compound. This will write the cyclo. 6 carbons are there. This is hex. HES hex. Sorry for my bad handwriting. Cyclo hex, and at position number 1 you are having the cyclohexene. So the correct IUPAC name is what? 3-nitro cyclohexene. This is the correct IUPAC name. You cannot do the numbering in the other way. See, you may think that sometimes you may have the confusion. Say for beginners, this thing is very, very important. Say you have written the example in that manner and put it the double bond here and NO2 here. And in order to follow the lowest possible lowest set of locant rule, you may think that 1, 2, 3, 4, 5, 6. This is correct one because at position number 1, double bond is there, and position number 2, NO2 is there. No, this is not like that. You have to follow the numbering pattern which includes both the carbons of the double bond. This will wrong. However, this is the correct one. Okay, now the various problems are there. You see, this problem you can do by your own now. There is no problem in that. I am giving you the hint. Start numbering from this direction. Okay. Now this is again quite simple here. Say this is 1, 2, 3, 4 and 5. At 3 position number you are having the ethyl. So 3-ethyl. This is a cyclic compound, that is cyclo. 5 carbons are there, that is pent. Okay. And at position number 1 you are having the ene. So your compound is what? 3-ethyl cyclopent 1-ene is the correct IUPAC name for this particular compound. Okay. Similarly, you can do for this one, say 1, 2, 3, 4, 5, 6. So at position number 4 and position number 5, you are having 2 methyls, so dimethyl. Okay. Cyclic compound, it is, cyclic compound, so you have to write the cyclo. 6 carbons are there, that is hex. At position number 1, double bond is there. Okay. In the similar way, you can write the IUPAC name of this compound, you can write the IUPAC name of this compound, right? Or you may write the IUPAC name of this compound as well, right? So try to write the IUPAC nomenclature of these compounds and answer in the comment section whether you are getting right or wrong. So now these are my final examples, the last examples, which are quite easy. 1, 2, 3, 4, 5, 6. So at position number 3 you are having methyl. What root is your hex? At position number 1 you are having the double bond. 3 methyl hex 1ene. There is no problem in that. This one is what? 1, 2, 3, 4. At position number 2 you are having methyl. So 2 dash methyl. Okay. And 4 carbons are there, that is but dash 1 dash ene. This is another way of writing this one. Okay, there is no problem in that. Now if you follow this one, say 1, 2, 3. Now this would be treated as a side chain because multiple bond is not in the ring. So at position number 2 you are having the cyclopropyl, right? And then prop dash 1 dash ene. So these are the very, very important thing, right? So you may write the name in that manner, okay? And then you can think in the another way as well, okay? So according to me, this one is the correct one, okay? Or if you think in the other way, then you can comment in the comment section. So guys, I hope these plenty of the examples are good for your practice. And this completes your IUPAC nomenclature of your unsaturated hydrocarbons. Okay, so I'll meet you in the next lecture with the IUPAC nomenclature of functional groups, compound containing of functional groups, right? And if you are watching video for the first time, please like the video if you are understanding the thing, okay? And do share with your friends as well, right? So that's it for today. Thank you very much.